dalgaları karşılayan gemiler gibi gövdelerimizle karanlıkları yara yara çıktık. Rüzgarları en serin, uçurumları en derin, havaları en ışıklı sıra dağlara. Hey, hey, hop, hop, hey, hey, hop, hop, hey, hey, hop, hop. Dostların arasındayız, güneşin sofrasındayız. Dostların arasındayız, güneşin sofrasındayız.
Good morning, everybody. Today I'm going to talk about total organic carbon and conductivity in pharmaceutical grade water systems. The content of my presentation will cover conductivity, TOC analysis, a bit about validating a TOC analyzer, and then I will talk about one of the instruments we have brought with us here today, which is on the table over here, PAT 700 TOC analyzer. So first of all, some talk about conductivity. Can you hear me okay? You can hear me? Yeah. Okay, so conductivity measurement in a water system is effectively a measurement of the ionic activity in the water. Compounds, when they're dissolved in water, will dissociate and break into their ionic form depending on how much energy you put into the water system. So these compounds are breaking into their ionic form and recombining again, and when they are in their ionic form, they can allow the water to carry an electrical current, and that's how we measure conductivity. So for instance, sodium chloride, made up from, of course, Na plus and Cl minus in their ionic form, and these can carry an electrical charge in the water. The more energy you put into the water in heat, typically, the more these compounds will tend to break into its ionic form. And as I mentioned, they then contribute to the conductivity of the water. Some substances dissociate, come apart very easily and more readily than others, and they're very reactive chemicals. So acids, alkalis, very reactive because they dissociate very easily and they react very strongly. So we have different materials in the water, different compounds. Each will dissociate sometimes easily, sometimes harder. So the conductivity measurement of the water is dependent on the chemicals in the water itself. So when you are measuring conductivity, you need to understand what is in the water to make the measurement correctly. So a conductivity meter will measure these ions as they go through the water, and they carry an electrical current in the water. So this dissociation is the key factor. I mentioned to make a compound break down, you need to put energy into the compound. Typically this would be heat. So in a water system, the hotter the water, the more conductivity you will see. So if we look at temperature versus conductivity, the more energy, more temperature you put in, the more conductivity you will see. Now, in pharmaceutical grade waters, just before the year 2000, we had an issue with measuring conductivity in pharmaceutical grade waters because each manufacturer of a conductivity meter would have a slightly different temperature compensation slope built into the analyzer. So you would select the temperature compensation according to what you think was in the water. So you can have 2 or 3 conductivity analyzers next to each other on the same water system, and they will give you a different answer. Yeah? So what they decided to do in the pharmacopoeias is make all of the analyzers report conductivity without compensation. no temperature compensation in the conductivity analyzers. So what you'll see in the pharmacopoeias is they will give you a table like this. It'll tell you the allowable conductivity for your water system according to what temperature your water system is running at. So the pharmacopoeia now says you will run the conductivity analyzer without compensation, no temperature compensation, and then you use the lookup table here, defined in the pharmacopoeia, to see if your water is within specification. Okay, so that was conductivity. Now to total organic carbon. The reason I talk about conductivity is because in the typical TOC analyzers that you will see on a pharmaceutical grade water system, they are effectively conductors.